Hello, nice to meet everyone. Just a little bit about myself. I've been working in the blockchain space past 7 years, building out protocols and blockchain ecosystems. Now been with Partisia for 2 years. I've been living in Zug, Switzerland past 7 years. And excited to be here. So, as I mentioned, I'm talking about the importance of privacy-enhancing technologies under the new GDPR guidelines for blockchains, and what kind of architecture should a protocol keep in mind on or build on to adhere not all the GDPR, but to all the data protection rules and regulations around the world. So what is a public blockchain? It is a combination of a database and a global network, and that's why it's causing trouble with the data protection rules. So here is a highlight of the biggest hurdles and challenges for public blockchains. We have data provenance issues on how to ensure traceability of data whilst keeping the user's anonymity. We have data minimization requirements, to only use the selected data for the computation that is only necessary as an essential, not the entire data, because currently the public blockchains are basically providing a database for absolutely all kinds of data, so how to enable selective disclosure. Then we have a data replication across global network in public blockchains. All nodes across the world are replicating all our data. And we have the hurdle and challenge of right to erasure. I would say this is the biggest one. Right to erasure and right to be forgotten. And then we have the pseudonymization problem. Effective pseudonymization techniques are required to disassociate identities from their sensitive confidential data, and user consent challenges. So we believe that the Web 2 actually has solved the regulatory requirement challenges, and it does have. So the GDPR, once it was adopted in 2018, all the Web 2 applications and services had to comply with them. So how does the architecture work there? We have a customer-facing infrastructure, which can be called public network, and it's the internet, where users request a certain information and receive the output, but only the transaction information will leave in the logs, like the time-stamped log information of different internet devices, like routers and firewall and so on. And then we have intranet, which is, for example, banks, which actually store and hold the user financial information and the data and assets. And through the intranet, this information will be then routed to the internet. Only the certain details which each individual user wants to get access to and has authorization to access to. And this is how it works and has been solved in the Web 2 space. And the internet is protected by firewalls and different other access authorization management. So taking back a look on the current model. So if we talk about transaction information, then in the Web 2 space or in the enterprise space, we have global network devices, we have routers and firewalls, which hold only the transaction data logs, who connected to whom, and the timestamps, as I mentioned. But in the Web 3, we have absolutely all kinds of user data, like their wallet addresses, the financial assets in their wallets, which is all revealed on the public chain. And the Web 3 public blockchains, they don't hold the actual assets, and they hold the actual assets and user identifiable data on chain. So how the asset storage is handled currently? It's in the Web 2 world, it's recorded and held on the enterprise intranets and in their private networks and clouds, and only the amount and transfer information is private, and only the authorized users within the enterprise can access it. And on the public chains, it's basically the source of truth. All the assets, wallet is just a mean for users to basically have the UX UI for their portfolio, but assets are also stored on chain. And how personal data is managed in Web 2, it's held inside the enterprise database in the digital cloud and internet, but it's only accessible to either the internal enterprise users, or if it's a public information, then it's revealed via website to public users. And in Web 3, whatever is contained in the public blockchain, all the user data is visible across the world on the Block Explorer or network. But how it should be is by combining private and public blockchain, similar to what Web 2 has done. The public blockchain should only hold the logs and transaction details, while private blockchain keeps the data and assets. And it's protected and verified by MPC, which I'm coming and deep diving into a bit, which is a privacy-enhancing technology. And the actual assets should be recorded and held on the private blockchain, but through multi-party computation and the collaboration between public and private, you will be able to see the logs and for audit purposes and transfer only that on the public side. And the private blockchains should hold the personal data, with public blockchain only providing the conduit for users to be able to access and manage it. So, coming back to what Partisia has been building, we have built our infrastructure since 80s with privacy by design, compliant privacy. One of our co-founders is Ivan Damgaard, who's known for Merkle-Damgaard hash function. He's behind the inventions of SHA-1, SHA-2 algorithm, as well as MPC, multi-party computation. We have many other top-notch cryptographers in our company that have been now optimizing and developing multi-party computation over 37 years. We have dozens of commercial applications and more than 1,000 research papers. So we've launched the public permissionless blockchain in 2018, a bit later, but we started off with a private network, and we have incorporated the multi-party computation into our infrastructure to provide data collaboration, data processing and management, and share of confidential data. Whilst it's distributed, there is no single intermediary that has access to it, so it's a distributed form of computation, whilst keeping the secret data confidential and encrypted. It's done so in a data being that is at rest, that is in process, and that is in transit. So we're also offering this MPC solution for other protocols, for example. So we have the interoperability built in place, and we do also offer it via an execution engine to Web 2 applications, which are based out of HTML environment. So completely versatile way of using it and leverage on MPC. And so it goes way beyond zero-knowledge proofs, which most probably all of you have heard of. The problem with zero-knowledge proofs is you can only use one user input and have a binary output. So you can verify if something is truth or false, or someone is above a certain age, if someone is vaccinated, but that's only limited down to it, and it's extremely expensive to scale it up to multiple users with the multiple data inputs. So that's what MPC solves. And we believe the compliant solution is a public and private hybrid network. This is what we have built several solutions out for NGOs, governments, enterprises that want to move over to Web 3, but still keep the data encrypted and secured, but want to compute on it and basically maybe collaborate with even competing institutions that are across borders. So how it's done is we're sticking to the same principle as Web 2. It's just a different philosophy. So we have clear division of public and private network, but both are decentralized. So the private network is also processing the data in a decentralized manner, where no one has a source of the data. It's distributed between different MPC nodes. So basically, enterprises are able to use the public chain for accessibility and traceability and auditability, but keep their secure and confidential processes and internal data protected by the intranet or the private blockchain, which is only between trusted nodes. And then the private and public network can collaborate between messaging protocol, and the smart contracts are also functioning between the both networks. And with the smart contracts, you're able to compute, the MPC is extremely customizable, so you're able to compute on who has the access, like you're enabled to customize the access management and which kind of data should be computed on, what is the output, because the output will be public to all these stakeholders. So we also have a jurisdiction management in place, which is crucial to adhere to all the data protection rules. I'm speaking about the GDPR in this session, but there are some other similar data protection rules enforced around the world. We have DPTPA in India, we have PIPA in Japan. Even California has CCPA, and several other jurisdictions have enforced similar rules than GDPR. So this MPC solution can be customized to adhere with all the other international data protection rules as well, or that are specific to each location, geographical location. And how we run our public network is each node operator has to pass KYB process, so they are detecting their jurisdiction that they run their node operation. And once a application or a enterprise is handling the processing of the confidential data, which has to be limited down to only a certain jurisdiction or country, then they can select the nodes which are specifically operating only in these countries or geographical borders. So basically we're enabling through hybrid blockchain public and private blockchain model with MPC and jurisdiction management, a new type of data market, or data market 3.0, where public network is accessible by general public, private network is accessible only by trusted parties, similar to Web 2, and it's all protected by multi-party computation. We have worked with Danes since early 2000s. I mean, most of the developer team is in Aarhus in Denmark. And we had a collaboration with the Danish Statistics and the Health Data Authority. So they're collaborating using our infrastructure to provide the data which is disassociated from the specific patient for analysts to compute on different results, either what is an outcome of a certain medication consumption or healthcare treatment, and so much more. We also have a use case currently running out of Japan. It's called Digital Platformer, which is using this private-public hybrid model to be able to detect fraud and money laundering and illicit activity between different financial institutions by enabling them to collaborate on financial data on a public network and keeping it all private, adhering to the data protection rules, because currently the financial institutions are only limited down to the insights internally, and that will open up the whole process. It will simplify the process and enabling financial fraud detection in a much more seamless way, thanks to this infrastructure that we have in place. So we believe we have solved the compliance issues and regulation issues, and that would be the model we propose, that has been proven to be efficient and adopted. And we have also many other cryptography methodologies to provide customizable privacy. And I'm happy to have any questions. If there are any questions, answer. Okay. So yeah, you can reach out to me or reach out to us at partisiablockchain.com. And thank you.
Thank you so much.